Halliday and Resnick, Chapter 5, Problem 773. A tin of antioxidants weighing 1 kilograms on a frictionless inclined surface is connected to a tin of corned beef weighing 2 kilograms. The pulley is massless and frictionless. An upward force of 7 newtons acts on the corned beef tin, which has a downward acceleration, and we're going to consider this downward positive for the acceleration, of 5.5 meters per second square. What are the tension in the connecting cord and the angle beta? So my strategy, first I'm going to figure out the force on M2, just what's acting on M2. And what we have is, we have 2 kilograms times gravity, 9.8, acceleration of gravity, minus this 6 that's pushing up. And that's going to equal 13.6 newtons. So I know that, and I also know that this box wants to slide down this ramp, and it's going to have, it wants to slide with a force of, so this box is going to want to go down the ramp with a mg sine beta. That's what we're looking for. So the acceleration is given to me, so we can say force is equal to mass times acceleration, which go to acceleration is equal to force over mass. And the reason I'm doing this, I'm just going to put all this together so I can solve for beta. So we know acceleration, which I do know, is going to equal the two forces. One is 13.6 newtons. That's taking into account the 6 newtons that's pushing up. And the other force is, and it's going the same way, it's mg sine beta. That's what we're looking for. And over the total mass, this is the total mass. One is 2, and the other one is 1, so that's 3. So this is 3 times A. We can get A on the same. It's going to equal 13.6. That's just the force acting on M2 here with the 6 newtons. It's computed in, plus mg sine beta. So all we have to do now is isolate sine beta and solve. So we have mg sine beta is going to equal to 3a minus 13.6. So we can say, we can just jump, since we know how to do that now. We'll say theta is going to equal to sine, let's don't say theta, let's say beta, since that's what we're using. Beta is equal to sine to the minus 1 of 3a minus 13.6 divided by mg. And when we do the math, you're going to get 17.2 degrees. Now, this was a good way of solving this problem without having to do any substitutions for t into, in other words, using simultaneous equations. So what we did is we got, this is the forces that was acting on this block here, M2. And we knew that the forces acting on, this is mg sine theta. We know the formula for acceleration using Newton's second law is just F over m. So what we did is we just added these two forces, since they're going in the same way, divided by m, and that's the m of both blocks, and then we just solved, isolated and solved.